All right, so today we're going to continue on with measurement, and we'll be looking at things like perimeter and area of different shapes. So just to recap, when you're asked for the perimeter of an object, you're actually just wanting, so say for example we have a square here, the perimeter is just the length around the edge of the object. Okay, so then when we're asked for area is the whole bit that it covers, like that. All right, so like the two-dimension. Now when we're going to go over all these formulas for area and perimeter, etc. But when we do that, we need to be really careful that they're all in the same units. So when we use a formula, they need to be in the same units. So that's why I've popped into your book the conversion unit thing there. So we need to be careful. If you're going from, say, millimeters to centimeters, so you have to, if you're going from here to here, you follow the arrow. That would mean you would divide by 10. Yeah, can you see that? Now, if you were going from, say, let's say you want to go from kilometers back to meters, you would have to times by 1,000. Now, I want you to be really careful too. When we come up to area, say you might have found your answer in centimeters squared, but they want you to answer it in meters squared. So be careful. If I'm going from there to there, see how you need to divide by 100 squared. So you've got to be really careful on your calculator that you do that. So it's different when you're talking squared, area units. And then the same will go for later on when we do volume. Say here, can you see if you're in centimeters cubed and you want to go to meters cubed, you actually divide it by 100 cubed. So you press divide on your calculator, put 100 and put the power of 3. Yeah, so you know how to do all that. So just be really careful with that. That would be some little traps that might happen for that. Sorry, and now the other thing that I've got down here is when we go later on to in volume, it was just all on this sheet though, is you might get asked to describe volume in terms of mils or milliliters or things, because that's what we don't go and say I've got a can of Coke that's 250 centimeters cubed. No, we say it's 250 mils, yeah? So if you look here, 1 centimeter cubed is equal to 1 mil. So if you want, I'll maybe write a little example there. So if you found something to be 250 centimeters cubed, that equals 250 mils. And if just in normal, like day to day, that's actually a cup. So a cup holds about 250 mils. Just so you know, if your answer, you might be able to tell I'm a little bit off. If you're finding out how much water is in a pool and you've worked out you've got 250 milliliters, you probably got something wrong there, yeah? It's enough water for your little toe. Okay. On your next page, you have these formulas which can help you if you're quickly trying to look at things. They've got formulas for surface area. So just to go over what surface area is, if you had a box like that, the surface area is when you're finding the area of all the faces of it. So say that was an open box, and so what you do is you need to find it. It's often if you were going to paint every side of it, think of it like that. So you've got to add them all up and things like that. We'll do some examples later on, so we'll see. So you might be missing some formulas that you use or you find that you use throughout this course. So pop them onto this page. If you've got one that's missing, write it on there. The page have Heron's formula? No. All right, so let's go and do some example questions. I'll zoom in a little bit. Now, straight away, there is one missing here. I don't know, so we might need to write this out, boys. So that says find the area of the triangle using Heron's formula. So this is one we don't have, so I'm going to show you over here, Heron's formula. Now, Heron's formula is when you have a triangle that's not a right angle triangle and you have all the side lengths. So you might have all the side lengths, but it's not a right angle triangle. So maybe write a little note to yourself, not right angle triangle. Because otherwise you would just use half base times height. Okay, so not right angle triangle. Sorry, I'll move that down a bit. So Heron's formula, what you need to do is it actually is equal to area equals the square root of S, S, and then it's S minus A times S minus B times S minus C. So you can see A, B, C are the side lengths of the triangle there, but what is S? So the way you find S is equal to, you add up all the sides and you divide by 2. So once you know what this is, this S, you can pop it into the formula where you see it. It's just the letter that they use, so that's how we have to calculate that first. Just the letter you know how the hypotenuse, they decide to use C? They've decided to use for this value, they often use the letter S. So let's go do the example so you can see. So I need to work out what S is. So S is equal to all the sides added up. So if I call this A, B, and C, I'm going to add up all those sides and divide by 2 and get an answer for S. So I'll do that on the... Okay, so I get S to be 5.75. So if I'm going to go now use the formula to find the area, I'm going to go A equals... Now, you can see the first I have to do 5.75, that's S. Then I do S again, 5.75 minus A, which was 3. Then I'll times it by 5.75 minus B. And 5.75 minus 5. Okay? So you type that, exactly how you see that in your calculator. Just remember that your calculator, you need to tell it your timesing in between there. Okay, so do that on your calculator and we should get the... Okay, so I got that to be 5. Now it said 2 decimal places, so 5.17. Now, before I did this question, I really should have checked that they were all centimetres, which they are. And now I've done that, I know my answer because it's an area question. It'll be centimetres squared. Okay, so our next example here is finding the area and perimeter in a practical problem. So it says a display board on a classroom measures 150 centimetres by 90 centimetres. So it's always good to draw a diagram just so you know what you're talking about. So I'm gonna tip it like that. Okay, if the ribbon costs 55 cents per metre, how much will it cost to add ribbon around the display board? So really, if you're gonna go, the ribbon around the display board means you need to know the perimeter. So let's do that for question A. We'll find the perimeter. So the perimeter of this would be 150 plus 90. Then there's another 150 plus 90. So perimeter equals 480. Now, this was in centimetres. Boys. Okay, so we have to be careful here because it's in centimetres, but this, they said it was per metre. So I need to change that to metres. So how do I do that? You go back to that conversion, and because I want to go to metres, you look at it and I have to divide by 100. So I end up with 4.8 meters. Now, so if I'm going to work out the cost is going to be 4.8 meters times, good, 0.55, which will equal, so it ends up being $2.64 for that one. Now, part B says the display board is to be covered with yellow paper. What is the area to be covered? Give your answers in meters squared. So you can either pick, do you want to change it now so it's already in meters squared, or you do it at the end? I might change it now. So instead of having it as centimeters, I'm going to say that is 1.15 meters, and this is 0.9 meters. So therefore, area of a rectangle, if you look it up, is length times width, which is 1.5 times 0.9. So I get 1.35, and I'm going to say meters squared. Okay? And it said corrected 2 decimal places, so we've made sure we're checking all that. 2 decimal places, meters squared. Good, that's what I've got, and there's your answer. Finding the perimeter and area of a composite shape in a practical problem. So composite shape means we've got more than one of our basic shapes. So if you have a look here, I could see how I could break this thing up, and that would be the composite shape. So often when we're doing these problems, you should break them up and just call it, even if you want to say this is shape 1, this is shape 2, so that we can work it out. So it says the gable of a window at a reception venue is to have LED light around its perimeter, but not along the bottom of the window. The window is 2.5 wide, and the height of the room is 2 meters, and the height of the gable is 1 meter as shown in the diagram. So it's saying calculate the length of LED that needs to go, and make sure you're seeing 2 decimal places. So it said it only had to go along here, here, there, and there. So if you're having a look, we've got, this is 2 meters, and that is 2 meters. Now what they've said is 1 is that distance there. So really, I need to know what this bit is, don't I, for the perimeter. So can you see, if I take that little triangle out there, where I've said that is 1 meter, this is what I need to know, and across here is that from here to here. How much is that? It's it's half of this one, isn't it? Yeah? So that's 1.25. That's where they're getting that, 1.25. Now this is a right angle triangle, so how would I find x if it's a right angle triangle? Yeah, good. So we're using, what formula is that called?
Pythagoras.
Good, Pythagoras. So we're going to do that. X squared equals 1 squared plus 1.25. And we're going to go solve, comma x, and find out what x equals. Do it. So I got 1.6. So now I know that that bit along the slant is 1.6. So if I go back to my question, and they want to know how much the perimeter of the LED, so the LED we need is, we said that we needed 2 plus 2 plus 1.6 plus 1.6, which equals 7.2 meters. The glass in the window needs to be replaced. Find the area of the window to 2 decimal places. So for the area, this is where I'm going to break it up. So I'm going to say area equals the area of the triangle, shape 1, plus the area of that rectangle down the bottom. And I start putting the things. Now, the formula for triangle, we can use half base times height. And this one we can do length times width. So if we Okay, so if you add in what you know about those things, so we knew the base of this was 2.5. We know that one's 2, so we've got that. Now we know this is also 2.5, and we knew the height, they told us that, was 1. So if we go and write that in, it's half times base, which is 2.5, times height, which was 1. That's the area of the triangle, and then we've got length times width, so 2.5 times 2. So you can just type that in your calculator and work out the area. Okay, so I did that and I got 6.25, and this is area, so what would the units be? Meters squared, good. And it said correct to 2 decimal places, which it already is, so I'm happy with that answer. Okay, so now we're going to move on to doing circles here. So we have to make sure we remember a few of the things about circles. So when you see the word circumference, circumference is the word used to say the perimeter of a circle, yeah? So we don't use the word find the perimeter of the circle, we say circumference of a circle. So to know what the circumference is when you measure the length on the outside like that. Now remember, the radius is from the center to the edge, and be careful, the diameter is from one side to the other. So you might want to write a note that the diameter is equal to 2 of the radius, isn't it? Okay, so just remember that. So down here, we've got some formulas for our circle. And so once again, they did not use the word perimeter, they used the word circumference. So you can essentially use 2 formulas. You can use this C equals 2 pi r or pi over d. I personally like to use this one. The reason I do that is because all your other formulas require r. You can't use d, diameter, in the area formula. So better to always, I say, go get your r and use your r formula. So if you have a look there, we've given the area formula is being given. So if you're finding the area of the circle, you're going to use this formula here. Okay. Done these type of questions, easy questions, circumference and area. So now we're going to look at more finding parts of a circle or things. So we need to learn some of these words. So when they use the word an arc, so if you see their arc, well, I might even do it in pink. The arc is a section of the circumference. So it's just the part of the outside. So can you see if you have a minor arc, it's because it's the smaller bit. And then the major arc is because it's the big part. They're asking you for the bigger part. So if they break this circle and they say find the minor one, you just find the smaller piece. Okay, so you have end up with a formula for arc. So you can see down here, they're saying here's a formula. Now, they're asking down here, you can see they're asking for an angle. So it depends on what part you're finding. So if you are finding the minor arc, you would use this little angle in there. If you're finding the major arc, you use the angle on the outside of it. Okay, so what you need is the radius. So you need to know the radius of the circle. You need to know the angle, so somehow, and then you use 180 and pi. All right, so that's that formula. Now, which is there. That's what it was. Yep. The other formulas, oh no, we'll do it, let's do an example here. All right, cool. All right, so find two decimal places, the length of the arc of angle 40 degrees. So they just gave me that angle there. at the center of a circle with radius, so once again they're telling me a radius as well, of 7 centimeters. So I know r equals 7. So if they want arc, if you go back to the formula on the other page, so we said arc equals, and it had the angle over 180 times pi. Okay, so if you substitute in all that data, we knew the radius was 7, the angle was 40 over 180 times pi. Type that into your calculator and you'd get a length. Okay, it's set to 2 decimal places, so I've plugged that in and I'm getting 4.89, and they said it was centimeters, so this is just a length. So the arc length, so I'll just say arc equals 4.89. All right, in the next example, the center of the circle with radius 10 centimeters, so I might just put r's there. The angle subtended by O at the arc ABC, so that means that has a magnitude, so you found the angle there. Find the length of the arc ACB. So that what they mean is just find that arc to 1 decimal place. So we'll use the same formula. S equals R pi over 180 times pi. So it is 10 times 120 over 180 times pi. Okay, so I get that to be 20 point, and it said 1 decimal place, 9, and this was measured in centimeters. So there's my final answer there. Okay, another question they can, oh, so, wait a minute. Didn't like that, did it? Nearly done. Sorry, let's get it out of the way. It'll come down, I just don't want it in my way. Alright, cool.
You put your shoes on. No, it's not the beer. Ew. Yeah, I know, but it's not.